Welcome to Astronomy Daily, your go-to podcast for all the latest in space and astronomy news. I'm your host, Anna, and I'm delighted to have you with us today. In this episode, we have some exciting updates to share. We'll delve into recent developments from SpaceX and their ongoing Polaris Dawn mission, take a closer look at new research revealing surprising insights about Venus's atmosphere, and explore the far-reaching implications of NASA's DART mission on asteroid Dimorphos. That's not all. We'll also uncover the latest discovery from the Hubble Space Telescope, which has located a fascinating mini-galaxy, and we'll look ahead to observing Salsa satellite's reentry event. So sit back, relax, and let's journey through the cosmos together. Let's dive right into our first story, SpaceX's Polaris Dawn mission, which has experienced yet another delay. SpaceX's ambitious Polaris Dawn astronaut mission was originally set to launch in late August from NASA's Kennedy Space Center in Florida. However, it has faced multiple delays, the most recent due to unfavorable weather forecasts and a helium leak. On Monday, August 26th, pre-flight checkouts revealed the need for further postponements. A subsequent attempt was made on Tuesday, August 27th, but this was thwarted by a helium leak detected just before the launch. To add to the hurdles, unfavorable weather conditions off the coast of Florida prompted the team to stand down from both the Tuesday and Wednesday launch windows. As of now, the earliest possible liftoff could be Friday, August 30th. As of now, SpaceX has not announced a new target launch date, but the team remains hopeful and is diligently monitoring both technical and weather conditions to ensure a safe and successful mission. Stay tuned for more updates as we follow the progress of this groundbreaking mission. Let's dive into the fascinating world of Venus. Recently, scientists have observed an unexpected increase in the level of deuterium relative to hydrogen in Venus's atmosphere. While this might sound like a minor detail, the potential consequences are monumental and could significantly alter our understanding of this mysterious planet. To understand the importance of this discovery, we first need to explore what deuterium and hydrogen actually are. Both are isotopes of the same element, which means they have the same number of protons, but differ in their number of neutrons. This difference in atomic mass can lead to variations in their behavior, particularly in atmospheric processes. Historically, Venus and Earth were believed to share similar HDO, or heavy water, and H2O ratios since both planets formed in the same hot region of the early solar system, where water couldn't condense. It's thought that water, along with other volatile elements like carbon and nitrogen, was delivered to these worlds by water-rich asteroids. This should have resulted in similar deuterium to hydrogen DH ratios on both planets. However, new data throws this assumption into question. By poring over data from the Solar Occultation in the Infrared (SOIR) instrument on the Venus Express space probe, operational from 2006 to 2014, scientists found that the HDO ratio is now 120 times higher compared to H2O in Venus's atmosphere. This change is primarily due to solar radiation breaking down water isotopologues in the upper atmosphere, producing hydrogen and deuterium atoms. Since hydrogen atoms escape into space more easily due to their lower mass, the DH ratio in Venus's atmosphere has been gradually increasing. More intriguingly, the concentration of water molecules increases with altitude between 70 and 110 kilometers above Venus's surface. At these altitudes, the ratio of HDO to H2O becomes staggeringly elevated, around 1,500 times higher than in Earth's oceans. This indicates that Venus's atmosphere contains much more deuterium-rich water compared to Earth, alluding to significant differences in the atmospheric processes of the two planets. So there you have it, another intriguing mystery in our solar system brought to light. These findings open the door for numerous questions and further studies, making Venus an even more captivating subject of astronomical research. NASA's Double Asteroid Redirection Test, or DART mission, has provided some groundbreaking insights into asteroid dynamics and planetary defense. The mission made headlines when it intentionally collided with the asteroid moon Dimorphos, and researchers are now revealing that this impact didn't just alter the moon's trajectory, it also significantly changed its shape. These changes are more complex than previously thought and could have far-reaching implications for our understanding of asteroid evolution. Originally, scientists had predicted how DART would affect the Didymos-Dimorphos system, but the real-world outcomes were even more dramatic than expected. The collision not only created a massive crater, but also reshaped Dimorphos from an oblate, hamburger-like form into a more elongated, football-like shape. This shift altered the moon's gravitational relationship with its parent asteroid, Didymos. Surprisingly, Didymos itself remained relatively unchanged, highlighting its firmness and rigidity, despite the debris scattered by the impact. Derek Richardson, a professor of astronomy at the University of Maryland and a lead researcher on the project, noted that the results challenge our conventional ideas about how small celestial bodies form and evolve. Traditionally, it was believed that such moons would naturally point their elongated axis towards the primary body due to gravitational influences. However, the post-impact changes in Dimorphos suggest a more intricate gravitational interaction. Interestingly, the gravitational disruption between Dimorphos and Didymos has led to some unusual orbital behaviors. The debris generated by the collision shortened Dimorphos's orbit around Didymos, and the moon might now be in a state of chaotic tumbling, akin to our moon always having one face towards the Earth but now knocked out of alignment. This tumbling could continue for a significant period as the system attempts to regain gravitational equilibrium. Looking ahead, Richardson and his team are eager to see how this altered state affects future space missions. The upcoming European Space Agency's Hera mission will provide a closer examination of the binary asteroid system by late 2026. Hera aims to assess the internal properties of both Dimorphos and Didymos, providing vital data that could refine our planetary defense strategies. This is particularly important because DART's findings are invaluable for real-world applications. By understanding how an artificial impact changes an asteroid's physical properties and trajectory, we can better prepare for the possibility of diverting potentially hazardous asteroids away from Earth. Our lab experiments and computer simulations can't replicate these complex gravitational dynamics as precisely, making missions like DART essential for gathering real-world data. The hope is that these insights will contribute to methods of asteroid deflection that are both effective and efficient. Richardson emphasizes that while the chances of a threatening asteroid or comet hitting Earth are low, they are not zero. With the success of DART, humanity now has an additional tool in its arsenal for planetary defense, offering a measure of protection against potential cosmic threats. As scientists continue to monitor Dimorphos and the Didymos system, one of the burning questions is whether the moon will eventually stabilize enough for future exploratory missions, including possibly landing spacecraft, to gather more detailed data. In essence, NASA's DART mission has not only furthered our understanding of asteroid behavior, but also paved the way for future space exploration and defense technologies. The revelations about Dimorphos's altered state promise to keep the scientific community buzzing with excitement and anticipation for years to come. And now let's look at a new discovery from the Hubble. Nestled against a backdrop of distant celestial bodies, a glittering collection of stars has been captured by NASA's Hubble Space Telescope. This wondrous sight forms the Pegasus dwarf spheroidal galaxy, also known as Andromeda 6. It's a modest member of a vast cosmic family, yet it offers monumental insights into the universe's grand narrative. Situated within our local group of galaxies, the Pegasus dwarf spheroidal galaxy is one of at least 13 dwarf companions orbiting the well-known Andromeda galaxy, also called Messier 31. In the grand scheme of things, these dwarf galaxies are the dimmest and least massive, yet their elliptical shapes and smooth star distributions hide a galaxy formation tale that captivates astronomers. Discovered in 1998, Pegasus dwarf holds particular significance due to its unique composition. Unlike many other galaxies in its category, it has a slightly higher content of heavy elements and a smidgen of gas that has, against the odds, supported minor star formation. However, this sparse raw material is still insufficient for creating new generations of stars, making researchers attribute the lack of it to the gravitational impact of its massive neighbor, Andromeda. Over time, Andromeda is thought to have drained Pegasus dwarf of its star-making gases, much like a cosmic giant siphoning life from its petite companion. What intrigues scientists is how these dwarf spheroidal galaxies, including Pegasus dwarf, come into being. Several theories are on the cosmic drawing board. Some suggest these mini-galaxies might form from fragments broken off larger galactic collisions, while others propose that the gravitational forces exerted by massive galaxies like Andromeda shape these small systems. Another hypothesis highlights the role of dark matter, a mysterious substance thought to make up a large portion of the universe's mass. It's believed that Pegasus dwarf and its ilk could shrink into existence among clusters of this elusive dark matter, warping space and time to create such fascinating formations. The light we see from the stars in Pegasus dwarf speaks to us from a time long gone. The galaxy's star population is predominantly older, having spent their lives in the low-density, gas-poor environment of the dwarf galaxy. Through Hubble's lens, researchers delve into these ancient stars' secrets, piecing together the life history of such galaxies and their roles in the larger galactic ecosystem. As we reported last week, on September 8th, 2024, an exciting event is set to unfold as the Salsa satellite re-enters Earth's atmosphere. This isn't just any re-entry, it's a notable milestone in space exploration and satellite technology. Salsa is one of the 4 satellites from the European Space Agency's ESA long-running cluster mission. What makes this re-entry special is that it will be observed live from the sky. Scientists have prepared an airborne observation experiment to closely watch and gather rare data on how the satellite breaks apart upon re-entry. This data is invaluable because understanding the finer details of satellite disintegration can lead to designing satellites that re-enter more safely and sustainably in the future. Over the past 7 decades of space exploration, although approximately 10,000 intact satellites and rocket bodies have re-entered our atmosphere, the specifics of what happens during these re-entries remain unclear. This experiment with Salsa aims to change that. The head of space safety at ESA, Holger Krauge, emphasized the importance of re-entry science in efforts to keep our orbits around Earth clean. He stated, to remove a satellite quickly from orbit after its mission ends and to prevent space debris, understanding the re-entry process is essential. The insights from Salsa's re-entry are expected to be groundbreaking, helping us refine satellite design and operations to minimize space debris effectively. The observation mission involves an aircraft equipped with over 20 scientific instruments, including cameras and spectrographs. These instruments are designed to capture as much data as possible when Salsa re-enters the atmosphere. Interestingly, the first of the cluster satellites to re-enter has been strategically scheduled to fall over a remote area in the South Pacific Ocean. This region was chosen to minimize the risk to populated areas, as most of the satellite will disintegrate within minutes of hitting the atmosphere, although some fragments may survive. The predictable nature of Salsa's re-entry time and location makes it possible for scientists to be in place with their observation equipment. This predictability stems from the cluster satellite's highly eccentric orbits, which cause substantial altitude loss at perigee, the point closest to Earth in the satellite's orbit. The re-entry observation mission, dubbed Rosy Salsa, showcases a collaborative effort involving academic and industrial partners, such as the University of Stuttgart, Comenius University in Bratislava, University of Southern Queensland, Hypersonic Technology Göttingen, and Astro Solutions in close cooperation with ESA. Jiri Silha, CEO of Astro Solutions, highlighted the mission's challenges, stating, "This is a very challenging mission due to the unpredictable nature of re-entry events. However, with experts in both science and technical preparation, we are confident in securing all the relevant scientific data from Salsa's re-entry." Thank you for tuning into Astronomy Daily with me, Anna. I hope you enjoyed our deep dive into the latest happenings in space and astronomy, including updates on SpaceX's Polaris Dawn mission, fascinating insights about Venus's atmosphere, the groundbreaking results from NASA's DART mission, discoveries by the Hubble Space Telescope, and the upcoming live observation of the Salsa satellite's re-entry. Be sure to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter, catch up on all the latest space and astronomy news with our constantly updating newsfeed, and listen to all our back episodes. Don't forget, you can also find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. This is Anna signing off. Catch you next time.